right. Welcome, everyone. This is Loic from Music Expo. Really excited about the session we're having today. As you know, every first Thursday of the month, we're having Dan and Piper talking about audio and answering audio questions that you have submitted in advance or you will submit live. But for this week, they have a special guest. So I'm going to ask Carmen to bring everybody on the screen. Right on. And we have on my here somewhere, right there.
EveAnna Manley, how'd you end
EveAnna
up here?
Manley. How did you come here? How did you make it?
Wait, how'd I get here? How do I work this?
Well,
This is not my beautiful house. This is not my beautiful car. Oh, it's you guys.
We are so honored to have you joining us this week. Hopefully, we're going to have a great time. For those who, I'm sure if you're tuning here, you know, you've seen the promotion. So EveAnna is the owner of Manley Laboratories, making awesome kick-ass audio gear. And I'm sure she will have a chance to talk about that, plus behind the screen or behind the scene. Sorry. Piper, Dan, how are you doing?
Good.
Awesome. Life's great, man. Like I get to see EveAnna's face and Loic's face and Dan's face, like some of my very favorite people, and all of you tuning in. Thank you for being here. This is No Stupid Audio Questions. We are answering all of your anonymous audio questions live here every first Thursday of the month. We have, should I go through the rules, Dan? What do you think?
Absolutely.
Real quick. All right. We've got 3 rules. Rule number 1, all anonymous, completely safe space. You can ask your questions at www.tinystereo.com, or you can go on to musicexpo.co and you'll find all the information after that. So it's fully anonymous. The idea is that if this is information that you just don't have in your arsenal, or things that you think you should have learned in school, or stuff that you can't find answers to on the internet, now's the time to ask these questions and get real practical answers. Because rule number 2 is that we do not ever answer a question with, it depends. Rule number 3 is that everybody has to have fun. So grab a beverage, grab some snacks, hang out, ask your questions in the chat if you want to, or go online. We'll answer a few live questions today, but for the most part, we're working off of a very specific form. Dan, do you want to show them the form real fast, just so that they see that everything we get from that website is simply anonymous? We get only timestamps, time and date stamp, what the question is, and what the category is. The password is all just really just a fun thing to see what you guys put in there. But yeah, this is the idea is that, you know, we're going to give you real answers to your real questions. And I'm so glad to have EveAnna Manley here. My bud, my dog bud, my motorcycle bud, my pal for life right here. EveAnna is, we're really lucky to have her here giving us her time. Congratulations on your vaccination, EveAnna.
I got my Fauci ouchie.
Hell yeah. And EveAnna is, if you guys don't know who EveAnna is, just like take 2 seconds and Google her real quick, because she is the head of one of the most important audio companies and recording audio companies ever. Every professional audio engineer probably has a piece of her gear or has worked on a piece of her gear. And Manley Labs is one of the most prolific audio equipment companies. And they also make awesome mastering equipment, mixing equipment, microphones, everything.
Preamps,
and
everything.
It's all out of
audiophile. Hi-fi gear.
Yes, thank you. All out of Van's tiny little head. And I'm also very lucky to have my my co-conspirator in this endeavor here, Dan Bacigalupi. Dan is a mastering engineer with me at Infrasonic Mastering, and we are here to answer all of your questions. So should we get started? Do you think, like, do you guys have anything you want to say? You want to say hi, or should we?
How do we pronounce Dan's last name again? I need to go back to school for that.
Bacigalupi.
Bacigalupi.
Exactly.
Okay.
And you have to do it just like that. They don't respond otherwise. So.
Okay, got it. Just getting everything clear.
Y'all,
by the way, you heard Piper call me Van. That's my nickname That's like the nickname I grew up with. But my
Right.
professional name is EveAnna Manley.
First gem.
My
we dropped
father
here.
was EveAnna Manley.
Whoa. Not
so,
that
Piper,
so
I'm
hey,
gonna leave. I'm gonna leave. I'm gonna
Rick,
let you do your thing.
I miss you.
I don't
Bye.
want to. I'll be around. I don't want to take such a real estate. You should be on the first screen. I just want to remind everybody to join us on the Discord after to hang after we're done with the session. And and also in the chat, if you can all remind us where you're dialing from, what part of the world, so we get a sense. And that's it.
Right on.
And I'm out.
Thank you, Loic. Thank you,
See you,
Music
Loic.
Expo. Thank you, Carmen, in the background. Everybody, thanks Carmen for running all this awesome little graphics and stuff. I don't know why I keep like doing hand things. I just like want to touch you guys. I miss you. Hey, y'all on the chat here, text your friends. I want everybody to text like 3 of your friends and tell them that EveAnna is about to drop some friggin' knowledge right now. I know it's a lot of pressure, Van, but you're gonna do fine. So, Dan, should we start?
Let's start. Do we want to dig right into to some of the
Yeah.
manly questions here specifically for
Yeah.
EveAnna? Let's do it. You know what? Let's go to like a kind of a simple start, sort of a more basic question here. EveAnna, can you explain how tubes work? I don't quite understand how the power gets stored. Also, what is your favorite tube and why? How tubes work?
them tubes, yo. Those tubes, what they do is they don't really store anything. They are primarily used as an amplifying device. So if you put a signal usually into the grid, into the middle thing, it acts like a valve, and it determines like how many electrons are going to go from the cathode to the anode, and the cathode is being heated up by a thing called a heater, which is like a light bulb filament.
What's cathode?
The cathode is a round cylinder tube thing that exists surrounding the heaters.
Okay, what's an anode?
An anode is also known as a plate, and that's usually where the electrons go to after they've left the cathode. So the grid, so if we're talking about a triode, 3 parts, cathode, grid, anode. If we're talking about a tetrode, there'll be 2 grids in there. If we're talking about a pentode, there'll be 3 grids in there. Anyway, the grids are literally like a wire that's wound around 2 poles. And when you put some electricity onto it, you can basically tell the cathode, like, how many electrons are you going to send up to the anode? I'm just putting things very simply. It's kind of like a water faucet, like a valve. And that's why the British people call them valves. So you're controlling the flow of electrons. And what magically happens is if you put a small signal in, you'll get a bigger signal out. And that's the purpose of these vacuum tubes, is to amplify music. So that's the simple way of saying things. But
I learned so much.
That's kind of how they work. In a simplistic form.
Well, that totally makes sense. Yeah, for sure.
Rad. Cool.
Yeah. And there's, there's things called solid state devices like FETs, field effect transistors, and you have bipolar transistors, and you have MOSFETs, and they work, they also amplify things. But the thing with vacuum tubes is they work with very high voltages. So you have very high headroom, and then you have very high fidelity. And that's why we like vacuum tubes.
Awesome.
That actually perfectly parallels into this next question if we want to go to it.
Yeah, are you sure it's not series? Is it parallel or series? I think this question is following the other one, so it must be a series application.
True. This actually is perfect in series with that question.
There you go.
Which is, I hear that higher voltages allow for more headroom in gear. But I don't really
they know that we were going to talk about this?
I know, it's perfect. But I don't really understand why. Is this because higher voltages allows the signal to be further from the noise floor?
Like I want to ask the person who asked the question, like, how tall are you? Because my ceilings in my house, they're like about 8 foot, above the floor. And I'm like about 5'3" above the floor, so there's a lot of space so I don't bang my head. It's kind of like that for audio. You want to have more than you need so that you're not clipping the audio signal, i.e. banging your head into the ceiling. Again,
That
a
totally
simplistic way to explain that, but it's like having more than enough horsepower in your car. I mean, I have a Volkswagen bus. It's a 1969 bus. It's got, I think, about 36 horsepower, and I totally have to downshift going up the Grapevine, because there's just not a lot of headroom, and I barely can get the car up the freeway. So, if you want to have good, wonderful audio signal, you want a lot of headroom.
Man, I think you should rename the bus the Volkswagen.
The Volkswagen. If I ever do an electric conversion, that would be. Yes. It's probably been done, but
right.
Piper, you are clever. We know this.
Thank you. So, what is your favorite tube? Because you didn't answer that one.
My favorite tube is the quiet one that is still functioning.
Dan, that series is into our next question.
Oh my God.
Next one, which is, EveAnna, are tubes still being manufactured? I've heard they're an old technology.
They are an old technology dating back over 100 years now, I think. Almost as old currently, as you. Hey, wait a minute. Tubes are currently made in China and in Russia and in the Czech Republic. And there's not really too much audio tube production here in America currently. Those are the three main places where tubes are made, because labor is cheap and it takes a lot of hands, a lot of manual labor to actually produce a vacuum tube, because you have to have a bunch of people sitting in a room, stuffing these little parts together and crimping things together. And I've been to a couple of tube factories in my illustrious career, and it's a very labor intensive and multidisciplined thing to get into producing vacuum tubes, because you're dealing with metallurgy, you're dealing with some poisonous metals, sometimes you're dealing with glass, you have to suck all the air out, and there's just a lot involved in making a vacuum tube.
Yeah. That kind of dovetails into another question that we have here. I just want to make sure we hit which was, is it difficult to obtain the tubes now? More difficult to obtain the tubes now, which obviously maybe yes. How do you account for the differences in supply if you're making calibrated equipment?
That's an excellent question. So, one way that we can mitigate shaky supply issues is to, when we find a big lot of them, to buy a bunch. So we have to invest a lot of money into carrying a lot of stock. So yeah, man. So for instance, the main tube that we're using in the variable mute these days, the 5670 that replaced the 6386 originally in the 90s. Gosh, yeah, this is back when David Manley was still around. He bought, I think, 18 or 20,000 of these tubes in the 90s, in the mid 90s. And we still are working off of those stocks today, right? When we can find a big lot of NOS tubes, that's the way to go. Now, these days, those tubes have been around the bases a few times, if you know what I mean, because I mean, from personal experience, like we'll get a lot of tubes in. Back in the 90s, we had a whole bunch of 607 tubes, and we used those in mic pre's and in microphones at the time. It's a little dual triode. Mm-hmm. And we went through them and picked out the ones that we liked, the ones that were quiet, the ones that didn't make any crunchy noises, and the rest of them were rejects. So I think we used about, 2,000 pieces out of 7,000 pieces, something like that. And then the guy that had sold me those NOS tubes, he called me and said, "Hey, EveAnna, I'm desperate to have some more of those 607 tubes. I got a customer just screaming for some. Do you got any to sell me?" And I'm like, "I sure do. I got 5,000 of them to sell." So he bought them back for me, because it had been a few years. He bought them back for more than I had paid for them. Oh. And those are my rejects.
Wow.
And then
that should be our retirement plan, right?
Well, all the money went back into the company, Piper. So anyway, we totally sold those back, and they went to another manufacturer of vacuum tube equipment, and it's not my problem that they might have been kind of noisy. And I hope they used them in a low gain circuit where it didn't matter that much. Not my problem. But anyway, but caution back to me, right? So these days, if I were, buying a lot of, a couple thousand tubes that were NOS, I have to be careful because what I did there could come back around to me as well. So when we find these batches, we seriously have to go through them and test them and qualify them, because it's really easy to clean up an old tube and repaint it or re-etch it or make it look like a new tube when in fact it's a pull. It's been around. It's recycled.
That leads to another question, which I'll just throw in here, that just came in, and I think I know the answer to it, so it should be quick, which is, under what circumstances would you send your manufacturing to China?
There's sometimes, okay. My company is based in Southern California in a town called Chino, and we always joke around, it's Chino, not China. And we're very proud of our factory and our workers. We've got over 30 people there working for us and building gear in Chino. And all the metalwork and most of the dollars in any unit is really coming locally. So that's a matter of integrity and pride for us. However, sometimes there are local suppliers that maybe we're outgrowing them, or maybe their technology is older and there's newer technology in China or more modern methods of production. And like a specific example is our printed circuit board manufacturing. We used to do that in-house, but we were doing it in kind of an old manner. And, literally like printing films and making silk screens and manually silk screening every copper board and then etching them and so on. These days, there's way better, automated things where you email a file to someone and 3 weeks later you get boards back. You know what I'm saying? So, and their quality was at least 3 times better, and their price was about a third of what we were paying before. So in that case, it's like we have to go win-win on this, right?
Yeah.
We can't just, but it wasn't just to make more money. It was totally a quality issue as number one. Because another thing, we've gotten burned so many times where we'll send like a knob or a piece of, some little metal part or something. We'll send it and get it quoted in China, and they'll quote it, and the price is like, wow, that's really less expensive, huh? Okay, let's order them. And, the first production run is great, and the second production run, it's like the color's a little off, but okay, they're usable. And then like the third and fourth production run, you're like, oh my God, are 10-year-olds actually machining these knobs with play school toys? Like, what the hell just happened here? So and it's not like we can just like go across the street and start yelling at somebody,
Right.
It's so sometimes some of these manufacturers overseas, it's really hard to get consistent quality control, and that drives us buggy all the time.
Yeah. Well, that's one of the things I've always loved about your company. I mean, just to throw it out there, is like just the consistency and the quality, and I know exactly what I'm going to get, or if I recommend your company or your products to someone else, I know exactly what they're going to get. And you guys do such a good job of standing behind your products too. I mean, it's awesome. Even like down to the packaging, you don't skimp on anything.
We've learned over the years, I've been doing this gig since 1989. So, and every time there's an unhappy customer, it rolls up to me. And if I could see an opportunity to take that, unhappiness and turn it into something positive or an improvement, we're going to do it. Because we don't want the next guy to have the same complaint. And
right.
And they were right. Maybe that box was flimsy, or maybe it should be a double wall box, not a single wall box, for instance. So,
well,
yeah.
You guys have been around for exactly one whole Taylor Swift. So All right. Hey, Dan, you want to ask a couple of these questions here? We
Sure.
have so many, like they're just rolling in.
There are so many. And I was,
Awesome.
this is great. And it actually, this kind of ties into what you were just saying, but maybe there's something you can add to it, which is just what are the challenges of remaining competitive with lower cost SMT produced professional audio products, since you build all of yours by hand in California? Or maybe how do you overcome that
This is
challenge?
part of the market.
We embrace that challenge. The SMD parts, and oftentimes they're even better sounding parts. Like we're not trying to stay stuck in 1989 technology at all. We've moved anything that we can move to surface mount production. We do, absolutely, because it saves labor, it saves space, it gets the parts packed in, tightly. There's certain parts, of course, that are not surface mount. They have to be through hole, like vacuum tube sockets, or the big film capacitors that sound so good that the whole output of your songs are going through. You know what I mean? So, but for things like side chains and the compressors and metering circuits and logic to throw relays and turn LEDs on, by all means, please, let's have all that as surface mount. And don't forget, all of us, our iPhones are all surface mount, and they're all made in China, and they all work pretty damn perfectly, don't they? So surface mount technology can be incredibly reliable. And because robots are assembling it, not humans, you can eliminate a lot of the human error, which is usually what we see with units coming off the production line. It's not going to be like, oh my God, that cap is just not working. That's pretty rare. It's usually going to be like, oh, Jorge just flipped the red in the black wires. You know what I mean? So that kind of thing. It's usually human error that contributes to any kind of failure. Initial failure. So when you can build something with a robot, it should be more consistent that way.
It's interesting because I feel like a lot when I read online at gear places, or especially when buying gear, people say handmade and use it as sort of like this must be better because it's handmade. So it's kind of interesting. Why do you think that is? Where does that come from? Where does the allure of handmade come from?
It's like artisan firewood,
Yeah.
Just having that human connection and knowing that actual humans actually did build this equipment. I mean, yes, that we might be using a board assembly that is surface mount, but a human actually needs to bolt it into the chassis and wire it up, right? And humans have to test it, and it's that human connection. And then, we're supporting American labor on this gig. That's what we're up to here.
That
so
totally makes sense.
Yeah.
Well, Van, I asked you here to ask you one very specific question, which is someone actually asked it, which is, would you please produce a Langevin Mini Massive?
I know you want a twin to yours.
I do. But actually, they asked another really awesome question that I hadn't thought to ask, which is, what are the best ways that we're going to get into a little bit more like technical stuff now, I hope, which is, what are the best ways to match impedance between analog devices? I read in a forum that adding buffer amp stages between the equipment or using a mastering console which buffered insert switches is the right way to go. This is correct. Could you explain also what a buffer amp is?
A buffer amp is usually what he's trying to say there, an impedance converter.
Okay.
So a buffer amplifier usually isn't going to have any amplification factor to it. It's usually going to be a gain of one, the gain of no more gain and no loss.
Okay.
And you're going to, usually the outputs of something are going to be a low impedance thing, and you want to drive something that's a higher impedance. So, for instance, there are circuits that you could use, like say in the tube world, say you used a cathode follower circuit. That circuit, the output impedance of that circuit will usually hover right around the value of the cathode resistor. So maybe that's, say, let's just make up a number, 600 ohms, right?
Wait. Back up.
Just say.
What's an ohm?
An ohm is a unit of measurement of resistance.
Is that like an ounce? or like an ohm?
OHM.
I'm just joking.
And
Okay.
we want to capitalize his name. Is it just a proper noun?
Because it's a man and he had a law.
And he had a big ass law called Ohm's Law, and we shall follow it.
So
Okay, so
audio
that's
basics,
600
yeah,
ohms.
thank
You know,
Okay, yeah.
let's get back into that.
Mhm.
Okay, you're not going to, if you have something with an output impedance of 600 ohms, it wants to what we call look up at the next device. If you were running that right into another thing that was 600 ohms input impedance, or God forbid if it were lower, like 100 ohms, you would load the thing down, you'd kill all the headroom, and it wouldn't, you wouldn't produce a lot of current, blah, blah, blah. So you want to look up. So it's a smart thing to design circuits that have low output impedances. So in tube world, we do that with what's called a white cathode follower, and that's named for a guy named Mr. White. It doesn't mean the color of anyone's skin. And the white cathode follower is got a much lower output impedance than a traditional cathode follower. For instance, I'm just talking tube stuff here.
Mhm.
And so having an output impedance of like, I think inherently about 20 ohms, we'll add a series resistance to combat capacitance in your cable, but then if we say the output impedance of that puppy is 50 ohms, say, we can drive anything. We can drive a truck. You know what I'm saying? We can drive your 600 ohms input impedance. We can drive your 1200 ohms mic input, on your mic pre. And we can drive traditional 10K, 50K, 100K inputs, in all your hi-fi and your other gear. So just remember when you're interfacing gear, you want to start with a low impedance and look up. You don't want to load it down with something lower than what you're driving it. So look on your spec sheets, and most of us manufacturers understand how this works, and it's very rare that someone's going to throw you a low impedance input. Okay. But like if you were trying to drive a speaker with, say, an 8 ohms impedance, you wouldn't drive it very far, would you? You know what I'm saying? So that's a simple thing. Now,
how would someone know that they have a low impedance output?
You look on your RTFM and you look on the specification sheet.
I know, but what's the? I know the answer, but what is the?
I don't know the answer without RTFMing.
How would you know? Like, how would you know if you have a device that has a low impedance?
You have to look it up.
Is there like a symbol?
Omega is the symbol for ohms, but
okay.
Yeah, you would go look it up on the specification sheet of your device, like what is the input impedance? What is the output impedance?
Okay.
And these days, a lot of times maybe that information is not provided, but look, if you don't have a problem, you don't have a problem, right? If you plug everything in, most stuff is designed to interface with each other. You're going to plug you're going to plug your microphone into a microphone preamplifier, right? You're not going to plug it into a loudspeaker.
Hopefully, yes.
That's true.
Right? Or you won't go very far.
Dan,
so that's kind of that. But with mastering consoles in specific, you want to, the purpose of the buffer is also to isolate equipment from each other. So you're going to reconvert that impedance, and also, that thing over there, or maybe you're multing two things together, is not going to reflect back and present a problem to what was trying to drive it or them. Okay, so, and you can make a buffer out of vacuum tubes, you can make a buffer out of integrated circuits or ICs, like little beetles, or you can make buffer circuits with transistors, discrete transistors. There's lots of ways to do that.
As someone who's definitely more of a pleb in this whole part of the audio world, do you know of any good resources where one might start to learn on some of this stuff? Is there a book or a place, maybe just YouTube, anything that you think is particularly good?
I tell you what, I'll share this personal experience with y'all. Since the change of government and the release of the national anxiety from my head, I have been able to absorb so much more information this year, because I'm not like obsessed with checking the news or worrying about the future of humanity. The University of YouTube has been very valuable to me. And there are so many resources on there from all over the world. And I mean, just start with anything. Arduino programming, start with that. Learn some code, because it will get you into like, well, how do you control that relay, and how do you make that thing switch, and how do you measure what that voltage is? Like, I learned so much watching some of that stuff on YouTube. It was amazing.
That's awesome. That's where I go to for almost everything.
So I mean, having the internet now is such an awesome resource. And I wish we didn't have the World Wide Web when I started. So it was books. And sometimes I had a really difficult time grasping the information or kind of understanding it. And because I did not go to school for electronics. I mean, I took my high school and college physics classes, but I didn't learn anything about vacuum tubes in those classes. I learned about Ohm's law, and I learned about math, and I learned how to learn. But these days it's so much easier. And yes, there are colleges you can go to, but man, there are great websites and YouTube videos you can watch to learn things.
That's awesome.
Wow, Van, you're dropping some really good knowledge on us here.
The
rest of us, we still have questions rolling in too.
Oh
which
my
is
gosh.
Awesome. That's pretty cool. All right. Yeah, I have a weird one that actually just came in with a really weird password. Password is Laura Palmer. So they must know that we're
Twin
Peaks
Peaks.
Go hack their computer.
Just super
Why are
weird
they putting
because
their passwords in
one
there?
of my really good friends and clients is the daughter of Ray Wise, who played the dad in Twin Peaks.
What?
Okay, so with Manley, we're going to switch gears for a second. With Manley plugins available with UAD, what can buyers expect in comparison to the highly sought after hardware that they are emulated from? So I'm guessing they're asking like, can I buy a UAD version of the thing and get most of the thing?
Yeah, you can buy a UAD model, a software model of an analog product, and you can pick up a Vox box in the Apollo series, working live as you're recording. You can, there's a massive passive, and there's a Manley variable mu stereo compressor. And to kind of quantify the difference, well, the technology that Universal Audio is using, they totally chop off some high frequencies around the Nyquist frequency. So you're not going to get like all that unmeasurable or unlistenable, inaudible. How about that word? Stuff up there, which, some people will say rings down and does affect the sound. So I'll leave that up to y'all to judge. But there is a frequency cutoff that does occur when you're dealing with the plugins. Okay. So, and actually that has affected some people's ability to turn in, HD tracks, because you will not have that high frequency content in the program at all.
I have been bit by that once. Yes. Turns out 96K is not 96K for all of their plugins.
Yeah. So that's just one thing to be aware of if you're working on HD tracks where you're required to produce some high frequency content there. That's one thing to deal with. Otherwise, to give it a number, based on the feedback I've gotten from customers over the years, I would say the plugin represents about 88% of what the hardware does. And you'll totally spend a lot more money to get that 12%, right? We can't compete with a $300 retail massive passive plugin that you can run whatever 7 or 9 times versus a 2-channel massive passive hardware that is like about $6,000. You know what I'm saying? So that's that.
So another question is asking about any insights you have in virtualizing hardware, such as the Manley Massive Passive into a plugin for places like UA.
There's the insights are, there's a lot of places where we create digital models of analog processes, like like databases and bookkeeping and running businesses. Like we used to do that stuff with paper and rulers and grids and things like that. And maybe that got translated into Excel and into more sophisticated databases over the years. With computer modeling of hardware gear, you know, you can buy, or there are free programs you can, like Texas Instruments has one called TI or TINA or something, where you can enter in a schematic into the program and it will model and predict its performance. And you can put, you know, with your mouse, you can drag a little multimeter and measure like, well, I'm going to have 4.6 volts at that point in the circuit.
I know what I'm doing tonight.
It's kind of fun actually. But so, you know, Universal Audio is capturing the actual schematic of the Manley unit or all the hardware units, and they're creating computerized digital models of the analog stuff. That's really what's happening there.
And for those
but they do that stuff. I'm not involved in that. I'm involved on the holding their feet to the fire part of it, where we measure the plug-in and we assess it and quantify it. And it's like the first time, like when they send one down, it's like, oh wait, that's got all odd harmonic information, but the real one is even order harmonic. Hey guys, this is not right here. Please fix this. You know, sometimes there are issues like that to deal with, but for the most part, they get it pretty darn close from the onset. But I work with some engineer buddies of mine to make sure that it is faithful to the hardware version. That we don't want our hardware like misrepresented, for sure.
Yeah, that's one of the things I love about those plugins too, is that it's, you know, it's clearly something that you would sign off on as far as quality. And of course, like David Berners and that whole crew they're all just super pros at what they do. And the way that they're able to emulate these pieces of hardware is really, really cool.
Very exciting company, definitely.
Dan, where should we go next? There's so many questions.
Well, there are so many questions. I've actually been really curious about this one. When I read it today, I was curious myself. How does Manley go about designing a new piece of gear? Like, does it come from requests from engineers, or do you wake up in the middle of the night? Oh, you don't wake up in the middle of the night with eureka moments? Okay, you do that too.
Keep saying.
Or also, what kind of decision making goes into moving a line of gear? Oh, wait. That
she just
puts
like
confusing.
4 different treats on the floor. One with like a
yes. See which one the dog.
No.
High frequency, low frequency compression.
Yes. Yep.
So yes, how do you design gear? How does that happen?
Well, first off, like I'll just dream and brainstorm about like, wow, that would be a cool thing to make, you know, and come up with an idea. Sometimes I'll be inspired by an old piece of gear, like, wow, nobody's ever recreated a so-and-so, right? Or sometimes there'll be a copy paste of bits of some circuitry we've used somewhere else, and we'll redo and make a new circuit a new product out of a couple things like that. Oftentimes it's, you know, just reading market trends, like, you know, what do people want for us? And folks write to us all the time. I had a guy write to me today, like, hey, have you ever thought about making and I'm like, actually, yeah. In fact, I've got some ideas on this, like doing some kind of modular thing. I'm not talking about a 500 series rack thing, but something where we have common gain blocks and then different kind of face plates that bang onto the gain block. So, you know, that thing is a mic pre, and that one with a different fascia on it is a LOP compressor. You know what I'm saying? So that's like, and that's what this guy was asking about today. And it's like, actually, I've been exploring that and trying to, you know, start brainstorming about like how to make the chassis so you could interchange these things or something. It's just, with all these designs, it's like you dream something, you set your goals high, and then you start attacking all the problems and, you know, work through it. But I've got an engineering team I work with. We have meetings on Google Meet every Thursday afternoon, like today, and we go through issues together. We think of new circuits. We think of different ways to attack problems. like that remote control, we're going to make it RF, we want to make it Bluetooth, we want to make an app, what do we want to do? So we just go over all kinds of technology and figure it out and start engineering.
Yeah. Wow.
It's fun.
So I have a question actually. So one of the things that I love so much about everything that you build, and all the things that are like originally even like Manley dynasty. I call you guys a dynasty for some reason. Legacy, like everything that you touch or anything that is generally like tube power amp related that comes from the original Manley brains. Is in my mind related to power. So that's one thing we haven't spent a lot of time talking about is power and the amount of work that you put into your power supplies and the cleanliness and the unlimited feeling of Manley power. Can you talk a little bit about that?
Manly power.
I know it's not like really a question, but like, could you talk about that a little bit?
Your power supplies are kind of boring, but they're usually important.
Important.
In the old days, in the very old days, you would have vacuum tubes living in your power supply. Oh, God forbid. You would have a vacuum tube rectifier that was, it was turning AC into DC, right? And you would build rectifiers that would hold a steady voltage, and you would build those circuits with vacuum tubes as well. That kind of technology we never embraced from the onset of Manley Labs, meaning David Manley didn't embrace vacuum tubes living in the power supply because there's a lot of problems with them. Like, you got to produce some more current and voltages just to heat them up. So they're kind of wasteful of power that way. And then they're going to die eventually, and they don't have as long a life as like a solid state diode or a MOSFET that you configure into a voltage regulator, for example. So traditionally our linear power supplies, and that means, a big old honking transformer receiving the voltage from your wall, throwing out different voltages on the secondary, and then you rectify those and turn them into DC. And then sometimes you're going to regulate them and hold a voltage, and other times it's not that crucial. Okay, so that's a brief description of a linear power supply. And that's what we used for many, many years. And one philosophy that David Manley had was to have a lot of capacitance after those rectifiers that are there to filter out the hum frequencies, 60 hertz here, 50 hertz in most other areas of the world. And that energy storage, which you can calculate and measure in joules, capital J, of course, that if you can have a lot of capacitance there, that can contribute to a big, strong bass sound, big, strong. It's like having a lot of ample headroom or torque, really. It's kind of like having a lot of torque in your engine. Kind of is the way it sounds, if you want to try to describe it that way.
Yeah.
Okay, so that's how we built all our power amps and everything for years. And that's kind of primitive technology compared to what we can do today. So these days, I became friends with a really smart dude named Bruno Putzis, and go look him up. He's way smarter than me, much. And Bruno was working for the Hypex company, and he was a real expert in switch mode power supply design. And they say, hey, Bruno, I know you can give us 15 or 18 volts with those little things all day long, but have you ever done something like you can give us like 300 volts? Because that's what we want. He's like, yeah, I don't see why not. So I hired him to design for us a really awesome new switch mode power supply, which we have trademarked, Manley Power. And we're really trying to deploy that in all our newest designs. And so in June, you will see the very first production run of the Manley box with the Manley Power switch mode power supply.
Awesome.
And I did that listening test last time I listened to that power supply, linear versus switching. I did that with y'all's boss, Pete Lyman. And
Oh.
I took a phono stage, a Manley Chinook phono stage. I took one with a linear supply, and I took one with a switch mode power supply, and brought 2 twin units. You know, the only difference was the power supply situation. And we listened together in LA, at Infrasonic LA, to some records that Pete had cut on the lathe sitting there. It was just so cool.
That's
and
amazing.
every single time we did blind listening with a switch that we couldn't tell which one was playing at any time. But oh my God, it was so easy to hear the difference between the two. Like, we picked the switcher as being faster and punchier and stronger sounding, like, every time. And it was miles quieter as well, because it's running at like 125 kilohertz or something. And it's very low radiating. And so, number one, that high frequency is above what we can hear. And number two, it's just not getting into the audio at all anyway. Whereas with linear power supplies, we are fighting hum intrusion at every turn. You know, we have to go through hoops sometimes. You know, if we've got that power transformer in the same chassis as everything else, you know, we have to put in metal shields, and we have to reposition sensitive components away from the big bad humming people and all that. We have to design the power transformers so they don't hum as much, like, and that's a challenge to get into a size, you know. It's like, oh yeah, we can hit that spec, but it's gonna be this big, you know.
Yeah.
So the new power supply is really awesome, and yes, we're all the microphones use it these days, and every chance we get, we're trying to re-engineer that into the older products too.
Yeah.
Is that something that someone who might own an older product could have installed into it, or would it?
I'm not even going to answer with "it depends." I'm going to just say no. There's too much work to take all the linear stuff out and reconfigure things. Like, we've got different heater voltages, and you got to change all the filtration capacitors. It's just too much freaking work, and it's like, no upgrades. Sorry.
I could have told you why the power supply hums.
Because it doesn't know the words.
Okay, so back to it. Okay. This is kind of a career question. Okay. So it seems like even as an electrical engineer, it's difficult to get into the gear manufacturing and music tech industries. Any insight as to why this is?
I guess you haven't filled out the careers link at the bottom of www.manley.com, because we're hiring. We need your help.
You heard it here.
We need good engineers. We are hiring. Go apply for a job.
Perfect. Van, I have a question for you. How do you, okay, I know only the answer for maybe like one or two of these, but how do you name your products?
Sometimes it's a very fishy question. Our audiophile products, I got on a tear about fish names. So I had this thing called the Manley Stingray, and I was drawing out this chassis idea, like literally on a cocktail napkin.
Yep. Is that where you drew down your trout put?
Piper in the puns. Caution. Danger. I was there with Gordon Holt, who was the original founder of Stereophile magazine, and we were sitting at a bar at a hi-fi show, and I'm like, oh yeah, Gordon, I got this idea for this power amp, and it's gonna be like this and this, and I drew this little thing, and it's like a square, but the sides are cut off, and I like it because it's very symmetrical this way, and no one else has made something that looks like this. And he's like, oh, it looks like a stingray. Presto! We called it Manley Stingray. Right. And then I was scuba diving a lot during those years, and then, you know, it just seemed like there's a lot of puns or double entendre names you can do with certain fish names, like Snapper. That amp, they're 100-watt monoblocks, and they're really punchy and fast, and they're kind of snappy, you know, and Snapper seemed to be the name for that. Another one is just kind of a gag. There are two of them. They're monoblocks, so they're mahi, you know, that kind of thing. I don't know, you know, a steelhead, that's another double entendre thing where, because it's got an autoformer on the input, you know, and the transformers are made of iron or steel, right? And it's like, and it's at the front of the circuit. It's like it's steel at the head. Yeah, steelhead, which is salmon or trout family fishy. So that's some of that. We like to kind of, I like to kind of joke around with the names a little bit and make them memorable. Like, you know, force is, there's 4 mic pre-channels in that, you know. And for a time I was naming some of the pro audio things as body parts, you know, for some reason. Like we had the backbone. Mastering switcher, but it, you know, it's a cool name because it's like the center, you know, distribution system of your mastering chain. You know what I mean? So some of these product names, whatever.
Dan, am I crazy, or wasn't there a question about the backbone?
There was. The question was just someone said they really enjoyed that piece of gear and loved it. Is there any plan to bring it back? Maybe do an updated version of it?
I would love to. The problem with that unit was it was extraordinarily complicated in the unit.
I had one of those.
It ran frightfully hot.
I burned my fingers.
Yeah, it's hotter than any tube thing that we make. There was a few reliability issues with some of that heat management and all that. And then some of the parts, like the output pot, that was a Penny and Giles pot. It cost us over $200 for just that thing.
Whoa.
Just him.
That thing is so silky smooth though.
Well, the thing felt good, but and the tracking was probably better than most other potentiometers out there, but never perfect either. So it sort of starts to become a waste of money in a way. And it contributed to probably as much as maybe about $1,000 on a retail level, just that one part, right? And I know you had another question about like parts costing and stuff like that, but you know, you have to multiply up your parts cost by a factor, and you could call it 4 or 5 or something, or sometimes it's 3, and then we're really struggling. We are not an audiophile cable company who mark up their parts costs like 20 times or something or more. You know, we're taking a very humble multiplier. But the cost of that backbone on the retail market was, what was it, like $6,000 or something like that. And we weren't selling enough of them at that price level compared to other lower costed similar devices like the Dangerous products. And we just weren't selling enough of them to keep them in production. So we killed it off. And I would love to revisit that product and try to really sweep it for cost to bring that retail price down. But the retail price being so high is a direct result of the parts cost contained within.
This question is kind of, I think also I kind of know the answer to it. I think you have done this at some point, even just in a prototype, but will Manley come out with an affordable analog summing platform?
Affordable. Define affordable. Affordable for me to manufacture it, or affordable for you to buy it?
That kind of sounds like it depends.
Well, we made those Manley 16x2 series mixers, and again, we discontinued them. Again, they were very cumbersome to manufacture and build, and they were thus expensive to manufacture and build, and thus, you know, they cost between $9,000 and $10,000 for those 16x2 rack mount mixers. I mean, could we do that less expensively? These days, yes, we could. If we change the layout, you know, how we construct it so it pops together faster, and also it was a solid state channels with tubes on the tube bus. That's a great place to get surface mount technology in there on the channels on the cards. So Yeah, it would be cool to revive that too. But that's another product in our that's sleeping in the stables right now that needs a scrub for cost. In the old days, people used to just design stuff and it's like, well, this is great. Oh, wow, look at that. Then we would add up the cost. The build cost is like, oh, hell, this thing is so expensive. Okay, the retail price has to be there. Oh, bummer. We're going to sell like 10 a year at that price, right?
Mhm.
These days, we don't do that. We start with, where do we want to be in the market? Where are our competitors? Do we want to be slightly above them? Do we want to be in the middle of them? Do we want to come out with something that everybody can afford? There's different layers, tiers of products that we can go for.
Mm-hmm.
And then we really work towards setting that budget of like, well, if it's going to retail for this, then we got to build it for that.
Mm-hmm.
And that multiplier factor is common to all the products we build. And I know some people find it hard to understand, like, how could that be $4,000? It's like, well, it costs probably more than $1,000 to build the damn thing. So, for instance, because we also have to factor in for parts and service, overheads, 401ks for our employees, American labor, distribution costs, marketing, everything with the company. We have to be able to pay for all these activities, R&D, everything. So no, we're not just raking in piles of cash here. That's not it. Even though some people are like, well, I can't understand how that could be $4,000.
But these are tools that we use, Dan and I use for, and people like us use for our jobs. It's kind of like a carpenter has to have a specific type of table saw or hammer or whatever. These things just cost money. And the better the tool, the better the job you can do. And I personally believe that, you have to make an investment in your career and your tool set. So, I applaud you, Van, for not gouging, and just delivering a really wonderful product all the time. There are a couple of chat questions here that we have answered. One of which we haven't actually touched on, which is reel to reel quarter-inch and magnetic tape usefulness going forward. Anyone still using them for studios? The answer is yes. I'm actually
Where?
in a room. Dude, I'm in a room. There are so many tape machines all around me.
Yeah.
And Dan, you can probably show the audience all of the tape machines that are around you right now.
There are tape machines and record players.
Yay!
And
I love it.
Analog
I don't
formats,
see
reel-to-reel.
young people embracing that though. Not really.
Yeah.
I mean, mostly like archiving and stuff, but I don't see people recording to tape right now much.
They'll get there. It's just expensive. But
Yeah.
okay. Dan, do you have any other questions for Van? I want to be cognizant of time and everything. I mean, we have gone through so much here and it's been so wonderful. We've answered almost every question that has been sent in.
Yeah, I'm just sort of in awe. I've learned so much on this No Stupid Audio Questions. This has been great. Honestly.
No stupid audio answers.
Exactly. There you go.
I hope not.
You guys, if anybody has any questions in the chat, you want to throw them in there real quick. We're going to jump on Discord. EveAnna has graciously agreed to, maybe against her will, join us on Discord for a little while. So
Discord
we'll be over there.
Discord?
Discord.
Discord
or Discord. And I
don't even know how it works, but I'm sure you'll guide
figure
me.
it out. We'll figure it out
together.
Some millennials will help you. I don't know. We'll figure it out. But anyway, EveAnna Manley, we appreciate you so much for being here and answering all of these really wonderful and deep questions about audio gear and manufacturing and tubes and electrical things. Dan, any last things that we want to tell Van other than thank you?
Just thank you so much. I still love my massive passive every day, so much appreciated.
I love my mini massive.
No, and I'm so glad you got to be our first guest. This is I think this actually really enhances the whole experience. So we're gonna have to see if we can get anyone else. But thank you so much for joining us here.
Thank you. I'm super honored. and always happy to share information. And you know what, this industry that we're all in, this pro audio industry, it's the best place in the world to be. And all of our, all of my manufacturing peers, we're like all buddies too. And it's such a inclusive and an embracing industry to be in. Like, we love each other, all of us, don't we? It's great. Thank you.
We do. All right, y'all. We'll see you over on the Discord. EveAnna, thank you again. Loic, Music Expo, Carmen, Dan, thank you again. And I think it's time for them to play the outro music, maybe something to turn this off. I have no idea how to actually end this.